This is our Unit 9 Day 4 video. What this video is about, we're talking about a new kind of probability, a different kind of probability we've gone over so far, and this is called conditional probability. So what conditional probability means, it's a probability that one event happens given, that's going to be our keyword here, given that another event already happened. So we have a special notation that we use for conditional probability. It's this notation here, probability of A given B. This little vertical slash is what we use for conditional probability. And though you would say that out loud, you'd say probability of A given B. Alright, so B, our second event, this is called our given event, and it goes second in that notation. So what we're actually looking for here is the probability that A happens given that B already happened. So B again is called the given event. That's what already happened. So if you want to calculate a conditional probability, we use this formula. It's probability of A intersect B, so this symbol right here means intersection, right? And intersection means both events happening. So probability of A and B happening over just the probability of the given. So you can remember this formula as probability of both over just the probability of the given. Just gonna go through what that means. We find the probability of both events happening, and this is called the intersection. That's what that symbol means. The upside down U means intersection. And then we divide that by the probability of just the given event on its own. So go through this example here to kind of show you what conditional probability means. So this is find the probability of pulling a 5 at a deck of cards given, that's our keyword that tells us it's conditional. Given that you pulled a number card. So we have two events happening here. So pulling a 5 out of a deck of cards, that's our A. That's our first event. We're trying to figure out the conditional probability that we pull 5 out of a deck of cards, given that this second event, pulling a number card, already happened. So that's our B event. So in order to find this probability, there's two things we need to find. We need to find the probability of both, and we need to find the probability of the given event. So both would mean that's both a 4 and a number card. That would be 4 out of 52. And the way we get that is that all 4 of the 4s are number cards. So those are both 4s and number cards. Sorry, for 5s. 5s are number cards. And that probability is 4 out of 52. Then we look at the probability of just the given event. The given event is pulling a number card. Right, so the number card, there are 36 number cards in the deck. And where that comes from is that there's 9 types of number cards in each of the 4 suits. So now to find this conditional probability, we put the probability of both, 4 out of 52, over the probability of the given, 36 out of 52. So again, this represents both over given. And the rest of this is just working with fractions, doing fraction arithmetic. So whenever we divide by a fraction, we take the bottom fraction, we flip and multiply. So at the bottom we'll have 4 over 52 times, flip it, 52 over 36, which makes 4 over 36. That will reduce to 1 out of 9. So again, we'll go through the same kind of process on the next one. So this one's rolling dice. So we have the probability that you roll an even number given, again, that's our keyword, that you roll a prime number. Right, so this one, prime number, comes after the given. This is our given event B. And this is our A event rolling an even number. So again, there's 2 probabilities we need to find. Probability for both and the probability of the given. So probability of both, right, this is something that's both even and prime, would be 1 out of 6. Right, and that 1 represents 2, because 2 is both even and prime at the same time. Probability of the given event would be 3 out of 6. Right, the given event is probability of a prime number. Right, and we have 3 prime numbers on the die. That's 2, 3, and 5. So it's probability of, again, both over given. So probability for both would be 1 out of 6. Probability for the given would be 3 out of 6. Again, we did our fraction arithmetic on the last one. It's going to be the same thing here. If we flip and multiply the bottom, it'll cancel out since we have the same denominators here. So the shortcut for this is we just cancel these out. So it's 1 over 3. So what we're seeing on these examples is that the given event will actually change the probability of that first event happening. Normally, pulling a 5 out deck of cards, you have a 4 out of 52 or 1 out of 13 chance. But given that you pulled a number card, that increases your chances to 1 out of 9. Same thing on the second example, probability of rolling an even number normally would be 3 out of 6, or 1 out of 2, but given that you roll a prime number, that probability goes down to just 1 out of 3. So on the back here, we're going to talk about a special case where the conditional probability doesn't change, and that's when we have independent events. So if two events are independent, and we talked about this on the day 2 video, one event happening does not change the probability of the second event happening. Since they don't affect each other, that means a conditional probability is the same as the probability of the first event occurring regularly, since the given event will not affect it. So for our notation, we say that the conditional probability of A given B is equal to the probability of A if A and B are independent events. And this works both ways around too. We can check to see if events are independent using this formula. So if we use our conditional probability formula, so probability of A intersect B over probability of B is equal to the probability of A on its own, that shows that B doesn't affect the probability of A happening, which means that A and B are independent. This just shows that it works both ways around. If A and B are independent, these two probabilities are the same, the conditional and the regular probability for A, and if you check and see those probabilities are the same, that means the events are independent. So it works both ways around. So that's it for this video on conditional probability. We're going to do an activity after this in class. There's a practice problem here. This is for you to try on your own. If you want to look up any other videos or resources on this, just look for conditional probability.